10E looks at volume and volume of pretty simple shapes. So the first lot of volume that we look at is prisms and cylinders. Prisms and cylinders both have one thing in common, and that's that they have a cross-section that doesn't change all the way through the shape. So for instance, a rectangular prism, the front shape is the same as the back, which is also the same as anywhere along this shape. So I could cut it through here and I would have a triangular shape. Same deal for a cylinder. It's cutting anywhere along the height of this, I will get myself out a circle. The only reason why prisms and cylinders are, I suppose, classified differently is that a prism does have to have a straight-edged shape, basically. So we can't have that curved edge that a cylinder has. But for the purpose of volume, we can treat them the same. The area of the volume is given by this area of a cross-section times the height or the length or the depth or the other side, basically. So you find the area of the cross-section or the area of the base, and then you times it by the length. Alright. So some generalized formulas. So we've got a rectangular prism, and we've got a square prism, and we've got a triangular prism and a cylinder. Basically, these volume formulas are looking at finding the area of one side, so length times width is like the bottom of this shape, and then timesing it by the third side. Length times length would be the bottom of the shape, and then timesing it by another length. Or pi r squared is the area of this circle, timesing it by the height. And a half base times height is the triangle, and then timesing it by the length. So this is all just following this prisms and cylinders volume formula. Area of a cross-section times the height or length or depth.
Some examples. So the first example is find the volume of the cuboid. Cuboid, we do have that formula, length times width times height. So we'll just use that, where length can be 6, width 12, and height 4. It doesn't matter which order we put that, we will get out the same result. So 6 times 12 times 4 gives us a result of 288. Volume is a centimeters cubed unit. So, or in this case, it's a centimeters cubed unit. So please make sure you put your units attached to that. The next example is a cylinder in cubic meters, and we want to 2 decimal places. So we're going to do the area of the base, so AB, times the depth, which is going to be 25 in this particular case. Radius is 5, so substituting in, and then just putting that into our calculator and solving. You can get an answer with respect to pi, but this question says 2 decimal places, so we'll go to the approximate answer, so 1963.50, and that's meters cubed. Next example is this one. So we do, again, it is a prism because we can cut it anywhere and get this front shape. So we need to calculate the area of this base, which is this one here, and then times it by the depth. Area of the base, the formula for this shape is given by a half of the top plus the bottom times the height. So half 10 plus 15 times 6, and then times that by the depth of 25. This is 75 times 25, which is 1,875. That was meters cubed. Lastly, although we've dealt with volume, there's the other side of this, which is capacity. So volume is the amount of space inside an object, but capacity is how much an object can hold. Think of it like liquid versus solid. So capacity is the liquid versus volume being the solid shape. There is a conversion between the two, so you can go from meters cubed to liters or 1,000 liters. 1 centimeter cubed is 1 milliliter, and 1,000 centimeters cubed is 1 liter. Now, in order to make sure we're right in the right units, You can do a conversion before doing anything else, and you can do a conversion after. So a drink container in the shape of a cylinder, and how many liters of water can it hold if the height of the cylinder is 20 centimeters and the diameter is 7 centimeters? And we need to give this answer to 2 decimal places. What I could do is I could go, I want to be in liters eventually. So I could start with my measurements being in meters. So I could convert 20 centimeters to 0.2. I could convert my diameter to 0.07. Or I go through and I find my answer with respect to centimeters cubed, and I can change that to milliliters, and there's 1,000 milliliters to 1 liter. So I could then convert it if I so wished. That method is actually what I'm going to go through now. So I'm going to use centimeters, find my volume in centimeters cubed, and then convert that to my capacity in liters. So I've drawn a diagram. It's just a simple cylinder with a height of 20 centimeters, a diameter of 7 centimeters, which means that my volume formula is pi r squared times height. My radius in this case is 3.5. So I've halved my diameter to get my radius. Pi times 3.5 squared times the height of 20. That's what I'm going to chuck into the calculator. And when I do that, I'm going to get out a result of 769.630, etc., etc. There's a few decimal points there, and I'm keeping all of those decimal points because when I do my conversion, that actually might make a difference. So I know that 1 centimeter cubed is equal to 1 milliliter. So this is the same as 769.69 milliliters. If I then convert that to liters, I've not quite got 1 liter. This is less than, so it's 1,000 milliliters to 1 liter, and I'm in 769. So my decimal point actually goes in here. It's the same as taking this value here and dividing by 1,000. This gives me 0.77, and that's liters. So I should have an L here, and then that would be what I would red box.